Geometry constructions. In this video we're going to look at construction number 22, which is the orthocentre of a triangle. We're going to look at three different cases: the acute case, the right angle case, and the obtuse case. So an orthocentre of a triangle is the point of intersection of the altitudes of a triangle, where the altitude of a triangle is the perpendicular line from the vertex of a triangle to its opposite side. So in order to draw a perpendicular line from a point not on the line to its opposite side, we can of course use construction number 3, a line perpendicular to a given line passing through a point which is not on that line. We can also use our set square to draw this perpendicular line for the purpose of this construction number 22. So because we're looking at three different cases, I'm going to give you three triangles to draw first, so that we have an acute triangle, a right angle triangle, and an obtuse triangle. So if we start by looking at this given dimensions, we have 8 centimeters in length, and if we were to do a rough sketch of our triangle, we can see we have 8 and we have 50 and 60. So we have AB is 8, the angle at B is 50, the angle at A is 60, and 60 and 50 is 110. So our remaining angle would be 70 degrees. So I'm going to mark a point A on my page, and I'm going to use my compass to measure out my 8 centimeters in length, or you can of course use your ruler. So I have 8. This is my point B. Take my protractor and measure my angle 50 degrees. Sorry, at A is 60 degrees. And then at B, I'm marking 50 degrees. And then where those two lines meet is my point C. So let's get rid of that excess line so we can just focus on the orthocentre. Okay. So to draw my altitude, I need to draw the line perpendicular from the vertex of a triangle to the opposite side. So I'm going to take the vertex C first of all, and I'm going to draw the line from C perpendicular to the other side, AB. So if I want the line perpendicular to AB, I place my ruler on AB, making sure it's perfectly aligned with AB. And then I simply take my set square, making sure it's sitting exactly on my ruler, and I can slide my set square in until it meets C, and then I will draw my line perpendicular to C. So in other words, this line that I've just drawn is the altitude. Okay. And again, you can check with your protractor, have you drawn a line of 90 degrees? And I have. And note, the altitude doesn't necessarily bisect the line AB. So I'm going to repeat for another side. So I'm going to take the side AC, and I'm going to take the vertex B. So again, I place my set square on my ruler, making sure it's perfectly in line with it and it's not sitting over it. And I'm going to slide my set square in until it reaches the point B, and I will then use my pencil to draw the second altitude from B, the vertex, to the opposite side, AC. And again, you can always check with your protractor, have you definitely drawn the line perpendicular to AC, which we have. So where these 2 points meet, so where these 2 altitudes meet, this point is our orthocenter. So we say note, the orthocenter is inside the triangle. Okay, so we then look at the right angle case. And we can draw any right angle triangle for this. Using your compass and your protractor. And you can measure our 90 degrees. So if I start by drawing my altitude, well, it's the vertex to the opposite side. So note that C, my vertex to the opposite side, well, that means that BC is my altitude. And if I was to take the side BC and I was to draw the altitude, well, note that that is AB. So really, by drawing the third side, and if I turn my page for this, if I line up AC and I slide my protractor, or my set square in, I should say, sorry, to B, well, that means that the point at the right angle is actually the orthocenter. So that's my altitude. BC is my altitude and AB is also my altitude, meaning B is the orthocenter. So we say note, orthocenter is at the 90-degree angle. Okay, so not to be confused with the circumcenter, where in the right angle triangle the circumcenter was on the hypotenuse. For the orthocenter, in the right angle case, it's at the 90 degree. So our third case then is the obtuse case. And again, we can draw any triangle where one of the angles is larger than 90 degrees. So again, what we have to do is take our side, I'm taking AB, and this time what you might notice that's interesting is if I want to find the altitude from AB to the opposite vertex, which is C, well, this time the altitude is going to fall outside of the triangle. So what we want to do is just draw a dotted line, because it's not actually part of the triangle that I've drawn, but just so I can draw the 90 degree, or the altitude, the perpendicular line, I will draw a dotted line as my guideline. So again, nice steady hand with your set square and your ruler, and then connect C to the opposite side. So this is my altitude. Okay, I then will take the other side. So I'm going to rotate my page for this, and I'm going to take the side AC, and I'm going to slide my set square in until it reaches B. And you'll see that at the moment my altitude is not meeting the other. So I need to extend my altitudes until they meet. So I need a nice long line. Again, making sure you have your ruler in the exact place you need it to be. And we can see this time my altitudes are meeting outside of the triangle. So my orthocentre. And again, so you distinguish between the altitudes and the sides of the triangle. You can, of course, use a different colour pen. So you can see A, B, C was your triangle, and these two lines are my altitudes. So 90 degrees to the opposite side. So we say note, orthocentre lies outside the triangle. So we had our three cases. The acute case, the orthocentre is inside the triangle. The right angle triangle, the orthocentre is at the 90 degrees vertex. And the obtuse case, the orthocentre lies outside the triangle.